morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, The Context Layer, the emerging stack for context-aware AI, brought to you by our friends at Collate, Graphwise, Precisely, and AtScale. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI ecosystem for enterprise leaders. Today, we're excited to welcome hundreds of attendees from around the world to explore one of the foundational challenges in enterprise AI, building the context layer, the emerging stack for context-aware AI. As enterprises push AI into production, context isn't a luxury, it's a requirement. Whether you're mitigating hallucinations, aligning responses with brand and policy guidelines, or ensuring traceable, compliant outcomes, context-aware architecture is becoming the foundational to trustworthy AI. This webinar explores the context layer, the emerging stack of tools, techniques, and workflows that inject dynamic, domain-specific intelligence into AI systems. We'll examine how leading teams are designing for retrieval augmented generation, grounding, memory, and orchestration to ensure outputs reflect the right data, tone, and constraints at the right time. We're honored to hear from a distinguished panel of experts today. Andreas Blumauer, Senior VP of Growth at Graphwise, Suresh Srinivas, co-founder and CEO at Collate, Jeremy Stinson, Chief Architect of SaaS, Precisely, Mark Palmer, Chief Marketing and Strategy Officer at AtScale, and Supriya, our advisory board member of Data Science Connect, who will be the moderator today. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features in the right sidebar. We'll be addressing your questions throughout the webinar, so be sure to upload the questions you'd like the panel to address. If you're wondering where your organization stands compared to others on your AI journey, check out the poll questions in the right sidebar. And finally, to learn more about how to build the context layer and enable scalable context-aware AI across the enterprise, check out the calls to action below throughout the webinar from our sponsors. Now, without further ado, I'm excited to welcome our panel to the stage. Welcome, everyone. And Supriya, once your camera pops up, I'll turn things over to you to moderate. There we go. All right, welcome. And Supriya, it's all yours.
Thanks, Brian. All right, so let's start with a quick intros. Can each of you share your role and how your work intersects with building or deploying context-aware AI systems? Suresh, you want to go first?
Hi, everyone. My name is Suresh Srinivas. I'm the CEO and co-founder of Collate. Collate is the company behind open source project Open Metadata. It's the #1 metadata management and context layer for data. Right? It's a unified context layer across your entire data stack. In Collate, we use Open Metadata as a context layer for enabling AI agents and assistants to help you do data, right, and get you business value from it.
Andreas, you want to go next?
Yeah, hi everyone. My name is Andreas Blumauer. I'm SVP Growth and one of the co-founders of Graphwise. Graphwise is a merger of two companies which have been around 20 years, roundabout, building knowledge graphs. So knowledge graphs go beyond, let's say, the context a data graph could provide. It injects domain knowledge, ontologies, enterprise taxonomies. We were very keen on using open standards from the very beginning. So our stack helps customers to have kind of a spectrum of context. So you can start with relatively, let's say, little context, and if needed, depends on the use cases and how the AI agents later on top should work. You can range, you have a full range and become more and more complex in terms of how the context can be described. So that's us, and looking forward to this discussion. Thanks for having me.
Wonderful. Jeremy.
Sure. Hi, my name's Jeremy Stinson. I'm the chief architect over at Precisely. I drive a lot of the technical direction when it comes to one of our SaaS products called the Data Integrity Suite. The Data Integrity Suite is a collection of our on-prem products. For those who don't know, Precisely used to be some other companies, but we're like 58 years old. So we have a long lineage in the data integrity market. And what we did is we took a lot of that great product and we rewrote it to be SaaS and cloud native. And so now we have data replication, quality, data catalog, data governance, and data enrichment all in one place on our suite. So glad to be here. Thank you.
And Mark.
Yeah, hi, Mark Palmer. I'm from AtScale currently. I've been a chief product officer in a number of companies and on boards, about a dozen companies and around the data integration and particular context management space, which I think we'll have a spirited conversation about. I think context management space is not a space. It's a very large constellation of different technologies that do different things. So, including being on a bunch of boards for those companies. And I lead investment analysis for enterprise software as well for Warburg Pincus, private equity firm and growth capital firm. So with AtScale, I'm here to talk about, I think what people are probably familiar with AtScale, it's a universal semantic layer, which many people would lump in with context. Of course, it does match that description, but it's very specifically about getting a consistent view of business semantics and making sure that the compute is 100% accurate for AI and BI uses, which is the context of the context slice that AtScale takes care of. I'd also just add that we're a big driver of the OSI, the Open Semantic Interchange, along with Salesforce, Snowflake, and others. So I'll talk about that a lot because I think standards is an important topic. But that's what AtScale does.
Wonderful. Welcome to all of us, and we will jump right into the core of our discussion. So, Suresh, here's my first question, and we'll do a round robins on the question. When we talk about the context layer in AI architecture, what exactly do we mean? And what are some of the key components, and why is this layer becoming essential in production grade systems?
Yeah, so context and semantics are the words that have become very fashionable and they are thrown around a lot, right? It's not precisely defined. A context layer from AI perspective and context from data perspective, and semantics, how data people are using it, they're all over the place. Okay, so for me, LLMs, right, and most of these foundational models, they are maturing, right, and intelligence is becoming a commodity. Now, intelligence without understanding, right, is not going to get you value, right, and that's where we come in, right. When I look at context layer, especially, right, with AI having generic understanding of the world, right, has to use your data, right, to create value for your business. Does it know what data you have? Does it understand your data? That is the key challenge, right? And to me, that's the context layer that we are building, right? Now, we started as open metadata started as a metadata management system. To us, metadata is key to understanding the data, right? This is what I now call as data context, right? It tells you, it has a unified metadata graph to connect, all your data real estate, right? Starting all the way from online transactional databases, all the way to ETL pipelines, and then data lakes, and data warehouses, dashboard systems. We connect all of this metadata into a unified metadata graph, which I call as data context, right? Now, what data context helps is, it helps you understand what data you have, where is it, and who is the owner of it, and what is the, whether you can trust it with data quality, and are there any operational issues, and also when to use and when not to use, and the compliance requirements of that data, right? This gives you understanding of data. Now, in order to understand the meaning of the data, right, today what happens is a lot of people, it's a tribal knowledge, right? You have business users, you have domain experts that are filling in the gaps of what this data means to business, right? And in the end, the goal of data is to create value for business, right? That's the layer that is missing in most of the metadata management systems today. And what open metadata does is it's got a semantic layer, right? And in data, a lot of people take semantics as defining metrics in a YAML file. That's not how we approach semantics. We talk about semantics to be a formal definition of meaning, right? That is machine understandable, that you can reason about and infer from and learn about your business, right? Without understanding the data, without understanding your business, your AI, all you're throwing is some technical schema, and it is a great demo, right? It's not going to be a production system, right? And with open metadata, what we have is 3 layers: data context provided by metadata graph, a semantic layer based on ontologies, right? We don't need to reinvent the wheel. There are RDFs, right? The technology like that OWL and all of that have solved the semantic issues for the web. It's the same semantic technologies that you can build on standards that already exist. So that's the semantic layer that we have. And then finally, what we have in open metadata is a collaboration of between users and AI and all of that. Through that, we are building a memory layer, right? So to me, when it comes to AI, it's all of these things, right? And then in addition to that, the access control, the governance, all of those layers also become part of context. So if you want to enable your AI, right, with the data, this entire context layer is important.
Wonderful. So, Mark, how would you define what context layer means in AI architecture?
Well, I don't. I mean, it's. I think this is one of the problems with the software industry is that a fashionable term comes out that's ill-defined and not standardized. And I mean, you've even got it right here. You've got a difference between metadata companies and graph database companies, right? And you've got data catalog companies that if you hit their websites, you've got, they'll all have the word context. Even like Data Connect, I've been on the board of a data connectivity company. They say it's all about context. So I actually think at this point, I mean, Gartner's not even really kind of defining the category. This is a category. It's sort of it's a good word. And the reason that why people are using it is that it's obviously everybody uses AI. We all know it hallucinates. It gets answers wrong. So we want to make them right. So I think, Suresh, you said this very well. I think the business problem is one that's super important. So how I think about context, though, is that it's everybody that's speaking of it is going to solve a piece of it. Metadata is really important. However, metadata is, in my view, it is a map of the information that exists in an enterprise. It doesn't actually compute the answer, and that's where AtScale differs in the definition of, and really not using the context layer term. It is a semantic and compute optimization engine where you do, as Suresh mentioned, you actually get the metrics out of there. So when you want the definition of revenue, it is in that layer. So that's how we define, and it's not so much of a category definition. It's how our customers, from Fidelity to Home Depot to, the long list of customers, they compute, they get their numbers out of that layer. And I think that's how I would define what's missing in the AI context and architecture to get accurate, 100% accurate answers out of what people are using AI to automate for. I think metadata is just about half of that solution. It sort of gives you the map, but what you actually want is a self-driving car to get the right number 100% of the time, not 60 or 70 or 80% of the time, what metadata forward architectures have. So that's how I would define what's going on within the context space more generally.
Got it. Jeremy.
So these guys actually did a great job explaining a lot of these different areas. So I'll touch on a couple other things. Like
Sure.
When we're building our AI applications internally, we have to keep a lot of different things in mind, including where the data is located, how to get to the data. Do we actually move the data into a data lake, or do we keep it where it is? Our preference is to keep it where it is because that's where the permissioning models are. That's where all the governance, that's where all the logging, auditing, and all the other things that you need in order to make this successful are. And the other piece that we really haven't hit on is the guardrails that actually help with making sure that the LLMs aren't just hallucinating with confidence. So real good example here is spent some time with a customer and their CFO was using a chatbot in order to get data out of their Snowflake database, linking it to some other data in their SharePoint, et cetera, et cetera. And nobody realized that the data was actually old. It was wrong. It had a whole bunch of errors in it because the pipeline screwed up the night before, and the CFO was going to walk into a board meeting that day. So when we talk about that, like metadata, this is where metadata comes in very powerfully. If you can have these specific guardrails sitting at the AI layer or the LLM layer inside the agent to be able to go look at this metadata to see when's the last time that was updated, what's the freshness of this, what's the data quality of this, being able to take a look at that perspective and add that extra context into how the agent is going to answer. It's really, really important because it gives you that level of confidence instead of just making the assumption that the LLM is hallucinating at scale. So lots of fun stuff.
A lot of fun stuff. Andreas.
Yeah, to me, it's quite fun because, you know, I've been around 25 years nearly in the semantic space. So it's absolutely not new to me. Back in 2000 or so, RDF came out. Tim Berners-Lee, you know, was his big vision, the semantic web. The interesting part is that this stack now is used in enterprises. So you could easily say that there's two tribes, yeah, graph tribes, LPG and RDF. And it's really all about how semantics can be managed in those two worlds. And I'm not saying that one is better than the other, that would be stupid. But it really depends on which use cases you want to execute on. So, and the really interesting thing with semantics is when you start using RDF, you can really scale out, and we call it a semantic backbone. Yeah. And the semantic backbone is kind of a more expressive semantic layer, if you want so. While we appreciate the Open Semantic Initiative, I think that's a really good way moving forward. And Mark, with AtScale, you're obviously at the core of that. And we believe that that makes a lot of sense. On the other side, when you look at ways to inject domain knowledge, there's not so many ways to do that. So it's quite clear you need ontologies which go beyond simple data mapping, data schema mapping. So the schema mapping alone does not the trick in many use cases. So you really need to inject specific knowledge. And we really see now more and more a knowledge first instead of a data first approach, because also our customers want to interlink structured data with unstructured data and everything in between. And here semantic backbone does a really good job. Plus the context obviously is not just static. Yeah? Context typically should include also procedural knowledge. So here we typically use PKO, that's an ontology which is used to describe procedural knowledge. And I think that was already Suresh, you pointed out long-term memory. That's definitely the next step towards multi-agentic AI. With a knowledge graph already, you can do a lot with GraphRag, for instance, obviously. But if you really want to orchestrate autonomous agents at scale, you need a semantic backbone. So a semantic layer alone wouldn't help you. That's how we look at it. Yeah.
Yeah. So all I'm hearing from you are like, you know, metadata and semantic layer are the most important thing, and especially when it comes in the context layering. And this gives me a good segue into next question around hallucinations. I mean, hear a lot about it, especially in the AI context. So reducing hallucinations is a major driver behind context-aware AI. So what techniques like RAG or grounding or schema enforcement have you seen work best to keep outputs tethered to reality? Jeremy, we'll start with you.
So I see it as a combination of everything. So RAG is really a point in time look. It's basically enterprise search from 15 years ago, just kind of solving a problem a slightly different way. And memory, especially with the popularity of Karpathy's LLM wiki that just came out a week ago that everyone's talking about, we have all these different concepts of how to supply context into the LLM. And there's a bunch of problems. We don't know whether it's right. We don't know if it's enough. We don't know if it's too much. We don't know if we're blowing out the context windows of these LLMs. And then which just leads to that hallucination. So in our world, what we're trying to do is build a grouping of multiple layers inside of here, where you have RAG, which is great for your search and finding some of the real data. You have your memory, which helps you with some personalization and some understanding of where you are, where you have been. And we do memory at both the user level, the role level, as well as the company level in order to help out with that. And then we always have the AI going back to the definitive source, the authoritative source, in order to grab that data to make sure that it's not hallucinating based upon what is actually in the memory or what's in another layer or something that might be cached. So we spend a lot of time working through these different things in order to measure the effectiveness of these different pieces to help to see whether or not we're getting the right answers and not getting the right answers.
Got it. Suresh, what do you think how we can reduce these hallucinations and bring it better for the context of AI?
So when it comes to AI, hallucination issues have become very widely known, and that's what people are thinking about. Yes, solving hallucination problem is important, right? And that's where semantics comes, right? You have an AI that has generic understanding of the world. How do you make it, make it understand your business, right? Understand the entities in your business and their relationship and all of that, right? Who a customer is and who is not a customer. And depending on who is asking the question, that context is also important to answer some of this, understand the concepts and answer the questions. And that's where, semantic layer, right? The data context describes the data, the structure and stuff like that. That's not enough. You need to give through semantic layers, not just the measures that you have on how you track the business, also what your business is. How would you describe it, right? In a way that AI can understand, right? Understand it precisely, not the way the graph rags and vector databases where you have sort of similarity approximate searches. You want precise meaning of things, right? And that's what and that's where semantics comes into play. And we did a recent comparison. We did a research study, and this blog is published, where we saw 7x improvement in how AI was generating SQL, right, through the semantic layer, right, helping AI understand, right, what it is doing. Now, just to go away from just hallucinations alone, we are talking about hey, where is the data, what is its state, and what is its structure, and what is its quality. All of that you get from data context. Through semantics you understand the meaning. But is that enough for AI to do a proper job? It is not, right? Your data has to be trustworthy, right? It has to have high quality. It should not have any, operational status should be ready, right, for AI to use it, right? So it goes beyond data context or semantics. It's also trust in your data, right? How do you make sure the data that AI is using is high quality and trustworthy and is ready, right, for use? And that's where open metadata doesn't stop at building a data context and a semantic layer. We also build unified discovery, observability, and governance, right? And through observability, we do data quality and operational status of the data and put that into data context so that AI is aware of the quality of data, the operational status of the data, the governance requirements of the data. So that is also important for AI to get the data right? So to me, you need a way to discover the data, understand the data, and trust the data. These are three pillars that I see. All of this needs to be checked if you want to get right outcome out of AI.
Yeah. So I hear you say that foundational data or the foundation should be very concrete to bring on those layers to make sure those hallucinations do not occur.
Yeah.
So wonderful. Mark, what would you say on this?
Yeah, I don't. I think we're talking about the wrong part of hallucinations here. The data, metadata, graph databases, vector databases. Actually, not vector, but we're talking about your enterprise data, understanding of your enterprise. Where's the definition of revenue? What are the what is the structure of your company? You say that very well. Those are really good things that metadata approaches can define. And of course, I was talking about metrics. So it's like, what is the real revenue number, right? The problem with sort of metadata oriented approaches is what it does is it feeds into AI's hallucination worst angels, if you will, right? It'll take the map and it'll keep guessing. It's like trying to give a Waymo just to go, right? You need much, much more context than just sort of the map. And in fact, as we know, AI will hallucinate its way to getting the wrong revenue number. That's why it's really important to have the compute layer in the semantic layer to actually give the number to AI that is 100% accurate. Because when you talk about things like benchmarking, which was just mentioned 7 times better, Atlan did a bunch of benchmarking. I've been watching this space for a long time. Data.world did a lot of benchmarking. There's the Tau benchmark, so you can actually measure this stuff, right? And you can start to see that some of the best metadata-oriented approaches do a good job at getting you from 60 to 70 to 80%. But when it's your number for revenue, it's got to be 100%, which means that you need a layer that computes that. If you want to call that context, fine. But to me, that's the real things that are going to be on a CFO dashboard that you can't even leave it to AI to guess based on a nice metadata map about what that number is. So there's that, right? So I think that's a really important thing to talk about. The other reason I say that we're talking about the wrong part of the hallucination problem is that because I think it's been touched upon a little bit, but I think the more interesting parts of context are what a lot of the startups are doing in the space, right? Not even the semantic layer companies like myself or the vector database companies, the metadata ones. Those are the companies that are managing context for the system prompts, the way that you want to guide the particular LLM you're using, the results that you get back from it. It's about establishing a trace of which prompts you actually used, which ones didn't work. It's about trying to manage the multi-stage agent spawning complex calculations that need to be intercepted. It's about having LLM as a judge, these kinds of things. These are the techniques that I think are interesting about solving hallucination problem. The aspects of getting just your enterprise data right is just a portion of it, and it's expanding far beyond this conversation. But that's how I think about the hallucination problem, which is a much wider view than sort of just getting your enterprise data result back right.
Got it. Yeah.
So one comment I would have here is, I think we all are in agreement that metadata alone is not sufficient. We've also talked about semantics is important, right? We've also talked about memory is important, right? And so I think metadata only approaches, as Mark is saying, is insufficient.
Right. Yeah.
And Andreas, what would you say? Reducing hallucination, how would you do that, and what techniques would you use?
Yeah, it's a mixture. We do use vector, but on top of that, it's ontologies. And when I say ontologies, it's something you can really use also for multi-hop reasoning. These are shallow ontologies necessarily. Use taxonomies. Also, SCOS is a great standard to have a segue into, for instance, document-centric systems. And of course, when the knowledge graph then is in place, which represents the majority of your data, so which is kind of a semantically enriched graph version of all the data and content you typically need, you can use that to deterministically retrieve data. So it's no longer necessarily the LLM, which starts to invent something, it really, we call it talk to your graph. So it's a natural language query, which is translated into a Spark query, and then it's 100% accurate. So we have, of course, we have customers that cannot deal with 99%. They need 100, and that's the solution for that. Yeah, that's one way moving forward. But it's not always necessarily 100% needed. So that costs money. If you want to be 100% accurate, it costs more money. If you're happy with 20%, it's also possible. So this is the beauty of graph when you use RDF, because you can start with relatively simple semantics and then grow the complexity by adding, for instance, all ontologies is needed, but not necessarily always. So this is how we propose to roll out a semantic backbone. So step by step, and then ramp up costs probably a little bit higher at the beginning, but you can then add more and more use cases on top. And here network effects come into play, because you reuse ontologies again and again. So you don't have to reinvent the wheel. And that's probably the most important part of the discussion currently. We talk context graph, context layer, whatever you want. You shouldn't do that anymore per silo. It should be done strategically. So the context layer, or whatever you call it, we call it semantic backbone, it should be set up as a strategic asset. It's an asset on its own. It's no longer just, sitting on top of a database, like in the good old days where metadata probably was always held up as well. So metadata outside of the silo is only becoming a valuable asset in the age of, or in the era of AI. That's what we currently see. And knowledge graphs definitely have, beauty is you can include the subject matter experts. Because when you ask, how do you reduce AI hallucinations in production? You need to include the subject matter experts, the economists at bank. They are not happy with wrong answers. They want to influence that. So they are accountable when wrong decisions are made. So they need to be able to influence the AI output. And when hallucination is observed, they want to go into the system and change that. Unfortunately, nearly no economist in a large bank can do Python. So you need an interface. And this is where, again, the domain models are coming into play. So you go to the ICE interface where the domain model, like ontology taxonomy in front of you, and as an SME, subject matter expert, you can then change things, relations, definitions, etc., and by that reduce or even erase hallucination. And that's what we currently see. Why semantic is also appreciated as an interface for the subject matter experts.
All right, thanks, Andreas. And Mark, Jeremy, at the start of this question, you mentioned about memory. So, layering the different semantics and different context, including the business objective and what we are looking at. So my next question is, Mark, you can go ahead, and that context can be delivered through retrieval or long-term memory. How do you think about when to use RAG, when to use memory systems, and how to balance them for dynamic, evolving contexts?
Yeah, I mean, again, I don't think that these are. I mean, the core question here is reducing hallucinations. I think there's been some chat in here about, in the chat about RAG reducing hallucinations. I haven't seen any evidence or benchmarking to that effect. The Tau benchmarks, I think, are the one that most of the companies I've been on boards are actually looking at as a faithful representation of, reducing hallucinations, which just means getting proper answers to questions that are in the benchmark, right? So like if people have things that they can share here about numbers, and I'd stipulate that the only true way of technique for some parts of context, which is the actual metrics and calculations and numbers associated with the business, is as Andreas said, is like that you've got the SQL that generates the answer and you give them the answer. That's 100% accuracy. So that's just one thing. Memory systems are, and I think of memory systems completely different than what I think you're framing the question about, right? I think the memory systems that I think are most interesting for context is memory of what the LLM actually produces an intermediate result, and using techniques like LLM as a judge to keep them on track and to judge each other's responses, hallucinogenic or not. So this is one of the techniques that, one of my companies spent a long time trying to, work with peer-to-peer LLM judgment on long-term memory of both the prompts and the responses. This is completely different than putting data in RAG and vector databases. This is not even that, right? So I think those are the areas that are the more interesting ones for memory systems. I'm sure the folks here on the panel will talk about memory systems in a different context, maybe around enterprise data, but that's how I view it. So I think I would just say to people that are watching, pay attention to the benchmarking that happens. Benchmark yourself. There are some good systems out there that are business oriented. So like it's not just the vendor saying, hey, you need RAG to make sure hallucinations go away. I think that's not credible. I'm not saying the folks here aren't saying that, right? I'm just saying a lot of marketing says that. And I think that's the best way for people that are really making decisions on how to reduce hallucinations should think about it.
Got it. Suresh, how would you answer this question around that context can be delivered through retrieval or long-term memory? How do you think about when to use RAG, when to use memory systems, and how to balance them for dynamic evolving context?
Yeah, so what I feel is, I'm not sure why we are considering RAG versus memory system, right? It is RAG and memory systems, right?
Okay.
RAG is answering, what information is relevant, right, for the activity that you're doing. Memory answers, right? And I'm talking about long-term memory here. Short-term memory is within a session, right? The long-term memory is all the experience that you've taught AI, right, in doing certain job, right? And that is relevant, right? So now without RAG, AI does not have, right, your specific business context, right, to do its job, right? And so it becomes then a generic intelligence at that point in time. It's not, tuned for your business, right, and the activity you are trying to do. With memory, right, without memory, you will keep saying the same preferences to the AI. Don't use this, do this, provide, this information this way, or this is the policy that we have, and this is how you should be answering the questions, right? This is our branding guidelines and all of those things. To me, those are preferences that you learn over a period of time. And so the way you build RAG is different, the way you build memory is different, but both of these two are important. Otherwise, it's like you're working with AI, and every time you have to you have to tell the same thing, right? And it's going to become tiring. It's like you have a brand new employee that has no context of what has happened in the past, didn't learn anything on the job, and you have to keep fixing the same issues again and again. So to me, both are important.
Got it. Andreas, how would you answer this question?
So, as Suresh said it, I think it's not either or versus or anything like that. It should be a combination of it. And so what we suggest here is to have on the one side, Graphwise system based on a knowledge graph. On the other side, a memory system which is connected to this knowledge graph. So it shouldn't be separated from each other. So it reuses or refers to the same entities, of course, in a more dynamic manner. So you see, okay, how it has evolved over time, which decision traces led to which results and so on and so forth. But this definitely should be all connected to the knowledge graph itself, to the semantic layer, semantic backbone. It should be one. Knowledge graphs are typically layered in named graphs. So the memory system obviously would be its own layer, but all the entities are interwoven and interconnected to the ontologies, and you could call it static business domain knowledge, which is in a different part of the graph database typically stored. But then you can really use both at the same time in combination, and that's a very powerful way to reduce hallucination and other stuff.
Got it. Jeremy?
I think it's very dependent on the application that you're trying to build. So for example, we just released internally, we built an application that allows for end-to-end development cycles. So starting at a Jira, having multiple agents, there's like 26 of them that actually run in order to build our software, deploy it under a feature flag inside of production. So memory is extremely important for that type of application to understand both the mistakes that the developer agent has specifically made and to adjust the next time it runs. Being able to supply the things that were done in order to do the QA agent. So memory is very important for those use cases, but there's some other use cases where it doesn't make as much sense. So you really have to make some decisions on what you're trying to build. There's a lot of tools in the toolkit. You really have to choose the right ones in order to solve the problem. And then to Mark's point, test. Testing is the most important thing in order to get this done and to get the understanding of whether or not you are or are not getting the right answer. And then the other thing is dealing with LLMs, challenge them to show you the proof, the citations of where they're actually getting the answer, or enforce that in the skill built into the application. So there's a lot of different ways in order to handle the problem. We're in a really, really interesting phase right now. Everything is changing on a week to week, if not day-to-day basis. And the only guarantee that I have is any decision I make today is probably wrong in 12 months. So we're not hesitating on making decisions in these things. We're just moving forward, building them, evaluating them, making changes as we go. It's a very fast moving thing, and we just have to kind of pay attention to what the bleeding edge is.
Got it. Yep. And this brings me to, because at the start, we also discussed about data sources, like, how different business context and data layering, and which we need to basically create a robust tool. Andreas, my next question is to you, that what role does orchestration play in context layer, particularly when managing multiple data sources, tools, policies, and you also mentioned real-time interaction. So all this is happening in real time. So how would orchestration play a role here?
Well, I think first of all, orchestration within the context layer plays several critical roles. So it's about dynamic data and tool management. So orchestration services enable seamlessly switching between hybrid stacks, so including various LLM models in cloud environments, maybe also proprietary data sources. So it allows autonomous agents to navigate disparate data sets, connecting structured graph context with unstructured documents without hard-coded manual intervention. So it again brings me back to the need to have a way to orchestrate agents using unstructured and structured data. It's super important by that having a hybrid setup like vector RAG plus graph RAG. So orchestrated governance and compliance is the next point I would like to highlight. So that means rather than implying governance as an afterthought, orchestration bakes governance as code into the workflow. And I think that's also super important to go live and in production at scale. So we utilize typically standards like Shackle to do so. So Shackle is the shapes constraint language, which allows to validate data consistency and structural quality. And that ensures that only trusted policy compliant information enters the AI workflow. That's also important. Shackle, think of a kind of a ontology language on top of OWL and RDF, which allows to define what valid data records really mean. And last but not least, real-time interaction and workflow engine. I would like to highlight that as well. So the orchestration layer, we typically realize that via GraphRag workflow engine. So our GraphRag component is also or is used as an orchestration layer, which manages the core logic for concept extraction, query expansion, enrichment, semantic enrichment when the answer is returned, So it supports both synchronous and asynchronous interactions, utilizing technologies like server-sent events, SSE, to stream real-time updates. So that also leads us to better explainability and policy check signals to the user. So that's a couple of thoughts on how orchestration within the context layer is typically working in an environment like the Graphwise platform.
Got it. Suresh?
Yeah, so when it comes to orchestration, it spans different things, right? Orchestration of various AI agents you probably have within a company, and how do they interact with each other. And it's a big problem, right? Let's say AI agents are like workers, right? And then they have to coordinate the work among them and all of that. Now for the sake of this webinar, where we are focusing on context layer, I will ignore that part of orchestration challenges, right, that AI has. Let's stick it to let's stick to the context layer itself, right? Now we've talked about context layer providing memory and RAG, and you have MCP with tools, and there are policies and workflows and all of these things that exist, right? Now, to me, orchestration layer decides what to use and when to use, in what order. You provided so much context. What is important context, and how do you prioritize it, right? What are the constraints of it, right? And what is the fallback behavior, right? If through context you're trying to do certain things and you cannot, right? And that to me is orchestration that is required within the context layer, right? It's a challenging problem, and like Mark was saying, right? So there has to be a lot of testing and validation, evals, and all of that, because the use cases in which AI is being used and how it works for one use case versus another use case, it may not work. There will be a lot of orchestration challenges, and there's a lot of learning to be had here. And that's where I feel you start with certain use cases, learn from the business problem, right? And start with certain use cases and learn right through how do you want to orchestrate the context layer, and how what to use, when to use, in what order.
Jeremy?
I think orchestration, again, like these folks have said, it's a very loaded term. There's a lot of different options of what you can and can't do with orchestration. Even from a data persistence layer, you have orchestration of and making decisions. Do you continue with a data lake or data warehouse, or do you move to a data fabric where your data is federated across multiple sources? You need to make some of these decisions to decide where your data exists and how you're going to get that data to the right place, and then how you're going to make those associations and connections in order to allow those disparate data sources and parts of data to interconnect and be usable for these type of applications. So there's a lot of ways to do this. There's a lot of companies who are doing things. Microsoft is trying to do this right now with their GraphRag, right? But the issue is with some of these large providers is they expect all the data to exist inside their ecosystem, which is just not a reality for most enterprises. So you have to make some decisions on what you're looking to do, what you're looking to achieve, and how you want to do it. You can build some of these orchestration layers pretty easily by yourself. There's companies out there like ours who will help with that. But you need to make a decision on, are you going to be centering into a single provider like Microsoft? Are you going to be having data spread across Snowflake and Databricks and Google and everybody else? There's a lot of different sources in order to deal with, and you need to make some decisions based upon that and what's best and easiest for your users and organization. Trying to push all the data into one centralized place may be great because it's easy in order to access and use, but it may be horrible because you have to recreate the permissioning model. You have to create roles. You have to create the synchronization of all that data and the quality on top of it. So orchestration is a huge problem. I think there's going to be a lot of interesting research that heads into this, and there's going to be a lot of different things that are going to be happening in the field. But I think some of the best advice that we've had internally is start small. Figure out where data should and should not live, and then make decisions and build the orchestration on top of that in order to deal with what you want to get done from a business side. Don't make assumptions that one size fits all, because it definitely doesn't. every one of your applications, whether it's the applications you've been running for the last 15 years or the new AI ones, they're all going to need their own specialities, and you need to make those decisions based upon that.
Mark?
Yeah, I was really confused when I saw this question because I think it implies that we're talking about a very old school type of orchestration, which I think we're doing here, right? Which we're talking about, how do you get data out of your enterprise sources into AI? You know, I think once again, if this is an AI roundtable, right, we should be talking about AI reasoning and agentic workflow, which is generated. It's not the old, like, I'm drawing boxes and lines and ETL workloads to orchestrate workflow to get data into my LLM. It's completely different than that. So, you know, again, I think the more interesting conversation and the things that are really important when you think about that term workflow is to think about how the agent is actually working, where there's, you know, it's generating the workflow dynamically. So how do you make sure that that stays on track from a context perspective? And that has to do with injecting the principles, for example, that, like, you know, the rules that a company has about how aggressively to interpret, you know, a customer that might be at risk, right? These are not encoded in a database anywhere. These are encoded in the sort of the human workflow and logic and expertise of a company. They're not even in a semantic layer typically. They could be put in one. They could be put into a knowledge graph. So dealing with the emergent behavior, and this is what, again, like, you know, the benchmarking systems that there's some domain specific ones about, like, one of the aspects of Tau is here's a person trying to make an airline reservation request. What does it mean to book the flight for Jeremy, Andreas, Suresh, and myself correctly? What is the correct answer? My wife always sits on the right side window seat. I always sit on the aisle, right? Like, what is accuracy? That information has not to be, bless you, has not to be encoded anywhere in an enterprise database, because it is not something that was typically used by the computing fabric, which is just generating reports on how many people book a seat on the right side of the plane. So I think the orchestration that's interesting is, how do these context systems that provide pieces of data work collaboratively with generated workflow that is the way that AI agents work? And that has to do, again, with you know, sort of measuring accuracy specifically for the type of, you know, data retrieval of metrics and using the semantics. How accurate is it? And a whole host of other technologies to manage state, failure modes, the prompts themselves, which prompts, how do you steer prompts, which switches do you throw when you provide a prompt to make sure that the orchestration that the AI agent's going to do is kept on track. I think those are the interesting areas of software development right now, which are related to metadata and semantic layers, but have to interact with a different kind of workflow than what we've been currently discussing.
Got it. I know we are reaching at the end of the hour, but very quickly, if you have to answer this question about looking ahead, where do you see context-aware AI architecture heading in the next 12 to 18 months? Andreas?
I definitely see more and more semantics coming up. I think that's 100% clear. Many vendors have stepped on that. Now the discussion is continuing. What kind of semantics is needed for which purpose, for which use case? Vendors also will start to understand in data is definitely one of the first steps, helping customers to get quicker to real working agentic AI. That's great to see. So finally, you know, it's no longer a siloed thinking that much. You have understood, at least a lot of vendors have understood, data has to escape the silos to some degree, that we can deliver on promises AI in the past 18 months or so. Otherwise, I think there will be an AI winter coming again. Semantics is probably the snow chain for that purpose.
Suresh? how do you see AI architecture heading in the next 12 to 18 months?
I totally agree with Andreas. It's semantics is going to be very important. It has to be formal semantics. It's got to include, entities, the relationships, the actions they can do, the business processes. All of this needs to be mapped. Otherwise, what AI can do is going to be limited, right? It needs organizational understanding. The second thing that I also think is, we are talking about agentic AI. We are letting them loose on the enterprise, right? On the enterprise data and the tools and all of that. Having guardrails and governance is going to be very important. The auditability is going to be very important. And, just, letting it completely loose is going to be, is going to create a lot of challenges. I think we need to take a methodical approach, and AI governance and guardrails is going to be very important.
Mark?
So 18 months, I think what you've actually already started to see is that so everybody agrees that semantics are important and knowledge, right? So, but what's going on now is there's a semantic war going on. If anyone caught, we just wrote about this. I wrote a blog post about it. I can share it here about Microsoft trying to control the semantics via Power BI and Excel through their own semantic layer, right? And what they just recently did is they turned off the ability for a Power BI user to use semantics from Databricks, right? They literally shut off all their Power BI customers through stopping a feature that let it use the semantic definitions through metric views. I think it is Databricks was turned off. Now, why did that happen? Because Microsoft's trying to control semantics, like the big hyperscalers, the big platform providers. They also get. I mean, it's not just the 5 people on this webinar that are saying semantics is important. This is a mega issue at the hyperscaler level. So the next 18 months, you're going to see a lot of fights about this. Right. We really believe that the OSI standard is a good path forward to make sure that things like Power BI turning off access to Databricks, because what's going to be next? Snowflake's going to be next, and Google backend is going to be next as well. So that's happening. The next thing that I think customers are getting more savvy about, actually asking questions about why do I care about context, right? Like everybody says context is important, but let's measure it. Right, like so when you start to measure things, you start to see cracks in the assumptions that certain approaches to getting enterprise data out actually help very much. Right, like we have one customer that used a metadata approach, and AI just merrily went along hallucinating the definitions of revenue based on the map and the metadata, and got the wrong answer and churned up tons of tokens. So starting to measure things, I think, is the second thing I think is going to happen in the next 18 months. And then I think you're going to see some really important strategic partnerships. A lot of people saw the investment that Snowflake made in AtScale recently. That I think that signals some interesting things that are happening, because the platform providers, the database, the providers of compute, need to be adding semantics into their platforms as well, like Databricks did. And that's why I actually just moderated a panel where Snowflake and Databricks were together talking about the importance of semantic. That tells you a lot. It tells you that their customers are asking for the same kind of context so that they can do better AI. So I think that's what's coming. A lot of war between the big players. Customers asking, being more sophisticated about it, and insisting on benchmarks, and a lot of strategic moves with the big infrastructure providers.
Got it. Jeremy, very quickly, what do you think what lies in these next 12 to 18 months?
Yeah, a lot of these folks stole my answers, so I can be very, very quick. I think we're absolutely heading towards a token war. I think where the pricing is going to be a big push. Especially if, for people who know, GitHub just changed their pricing model, and it's absolutely insane how much they're going to be charging. I think you're going to see a huge push for local models. These open source models are amazing. I think that they have some good places inside of the environments, and I think people should be taking a look at them and how to use them for certain reasoning problems and stuff like that, instead of paying the big providers. And you're going to see a lot more push into the governance. The old practices of keeping your data clean, keeping your data right, keeping your data with the right levels of enrichment and access and everything like that, that general care and feeding of your data is still going to be important, but data governance is going to be a lot more important as we go. So hopefully a lot of companies are paying attention to that, because AI is just another user on your network who has access to your data and is going to make decisions for you. So you have to make sure you have the right constraints in place.
Got it. I know we have a couple of questions in our Q&A section. So I'll take like one question, and I'll ask Ken's question, which is, how do enterprises know what portion of docs would benefit from more semantic structure, like graph extraction, other metadata? And this work that takes time, and it seems like enterprises would do it more if hallucination could be tied to subset of docs. So whoever wants to go ahead with answering this question.
Can you put it back up? I'm sorry, I'm still trying to understand it.
I mean, it's basically all about semantic chunking. So it's obviously about docs, documents, Ken is asking. So unstructured data. There are various ways to do semantic chunking. Vector is one, which is relatively imprecise. If you have ways to first understand each and any portion of a document, specifically mapped to a business domain ontology, you can do better. So that's definitely another reason why graph-based document handling makes quite a lot of sense. We've seen it also, for instance, in data documents. Data is a relatively often used standard for technical documentation, and there are many others like that. So you can do this semantic chunking also in componentized content management systems quite nicely, and this increases the accuracy of a system quite dramatically.
So I find it fascinating that Andreas read into that question was about semantic chunking. I don't read that at all into the question, which is why I wanted to stare at it. I mean, I love your answer. Right?
I read it like, what portion of docs would benefit from more semantic structure? That's how I read it, but
my interpretation of, so how do you tell which portions of the documents would benefit? I mean, I guess that, to me, I leap to like, what's the use case, right? Like, for example, legal tech, right? Like if you're building a legal tech system, maybe that fits into your ontology point, Andreas. But I think this to me, my read of this is it's got to do with the use case, because we're kind of assuming unstructured here in that. So, but if you're building a reporting system for quarterly reports, sales reports, well, then the documents that are interesting are very different, and the numbers that you use are very different. So to me, that's a use case forward question in terms of answering it. Depends on which use case you're doing, and then figuring out which portions of unstructured documents would need that sort of chunking and understanding, and then go from there.
Got it. Thanks, Andreas. Thanks, Mark, for answering the questions. So with this, we will end our webinar. Thank you all of you for this fun and great topic that we all discussed today. Thank you all.
Thank you, everyone.
Thank
you. Thank you all for joining us today. A lot of great insights from our panelists. If you missed any of the webinar or want to rewatch anything, the recording will be available a few minutes after the webinar if you refresh this page, and available also tomorrow on our YouTube page. Thank you again to our partners at Collate, Graphwise, Precisely, and AtScale. And don't forget to join us for our conversation tomorrow on agent observability. We will see you all next time.